So hello students, today we are going to discuss ionization energy, which is a subtopic in periodic properties, and also it is an important topic for IIT JEE and NEET. So directly questions will come from the ionization energy. So now we are going to start ionization energy. So what is mean by ionization energy? Means, so for example you have any atom circle. So if you know already, in the center of the atom nucleus will be presented. And next, for example, one more shell is there here. Okay, here one more shell is there. In the center nucleus is there, and the electrons will be present in the shells. Yes or no? Electrons are rotating around the nucleus in a circular paths. So here what is meant by ionization energy? Means the energy is required to remove an electron from the outermost shell of gaseous atom, neutral gaseous atom. So if I remove the electron from the outermost shell, this is outermost shell, right? This is inner shell, and this one is the outermost shell for this atom. So how much energy you need to remove electron from the outermost shell? That energy is called as an ionization energy. Did you get it? So the energy required to remove an electron from the outermost shell of neutral isolated atom, we can say neutral. Why we are calling it as neutral? Means when it is neutral only we can remove the electron, and isolated means separate atom should be there, one separated atom. So it should not be combined with other atoms. So at that time, if we remove electron from outermost shell, means that is called the ionization energy. So we can write the statement, right? The amount of energy is required to remove an electron from neutral isolated atom. You can say here neutral isolated atom. Okay, neutral isolated atom. The amount of energy is required to remove an electron from a neutral isolated atom is called ionization energy. So how much energy you need to remove an electron from the outermost shell is called, that energy is called as ionization energy. So now the ionization units of ionization energy. Simply I can write ionization energy as IE. What are the units means? One is electron volts per atom. How many electron volts per one atom releases, or we can say in kilojoules also we can measure kilojoules per mole, we can write, or else we can write kilocalorie per 1 mole. Per 1 mole how many kilocalories it is releasing? How many, sorry, how many calories it required to remove an electron. So these are the units of ionization energy. Now if you move to the, so how we can say is, for example, neutral gaseous atom is there, like X, neutral atom is there, gaseous atom is there. So I am giving some energy, right, to remove an electron. This one I can say as IE. Then what it is doing is, it is losing one electron. It means positive charge will get and one electron will get. Okay, here the energy is observing. So when the energy is observing, that type of reactions we can call as endothermic reactions. So that's why ionization energies reactions are Endothermic reaction. Endothermic means it will absorb the heat energy. Thermic endothermic reaction, we can say. Okay, reactions. It means energy is observing here. That's why when energy absorbs, that type of reactions are called as endothermic reactions. Now, so we got the ionization energy. Now what is there? So the factors effective. First of all, if I'll remove one electron means it is unipositive ion, right? Unipositive ion. Yes or no? Uni means one. Positive. One positive charge is there. Unipositive ion. Now IE2 is there. Second ionization energy. We can say second IE. Or else we can represent with IE2. Okay. IE2. Now what is mean by IE2 means? So you already removed one electron from the outermost shell. Then the energy is required to remove an electron from unipositive ion. Already here one unipositive ion formed. So from that if you remove one more electron means that is secondary. Unipositive ion is called as IE2. Okay. This is IE2. How we can write the reaction means X plus this is unipositive and again energy which is gaining to remove electron. So it will turns into dipositive. 2 plus one more electron. This is also an endothermic reaction. Now you just tell me for first electron energy is more or else second electron energy is more. So for the first electron energy is less as compared to second electron. Why? Because when we are moving, so the first electron is already going, the attraction force between the nucleus and the electron will be more for second electron. That's why the energy required to remove electron is more. So we can write here simply IE2. Generally, this is generally, not every time, generally IE2 is greater than IE1. Okay. Now, if you go for factors affecting the IE, factors affecting the IE, factors affecting ionization energy. You can say or else IP also. Instead of IE, you can say ionization potential also. Both are same. Factors affecting the IE or IP. The first one is, in the factors, first one is atomic radius. So what it is? Atomic radius. So what is mean by atomic radius? So now you tell me, for example, one atom is this much size. It has this much radius. And this one is this much big. So this is the nucleus center of the atom. So electron is here and here electron is here. Now you just tell me from here to here the distance is more or here to here the distance. Atomic radius, for example, I'll consider this as A. Next this one as B. So for A the atomic radius is more or else for B atomic radius is more. For A atomic radius of A is more than B. Okay. Now the radius increase. It means the attraction force between the here the attraction force between the electron and nucleus will be more or else here it will be more. Here it will be more. Why? Because Distance increases from the nucleus to outermost shell. So atomic radius increases. Atomic radius increases means the attraction force decreases. When the attraction force is less between nucleus and outermost shell, we can easily remove the electron. Got it? We can easily remove the electron from here as compared to here, because here the attraction force between the nucleus and the electron is more as compared to here. So what we can write here? Here simply we can write IE. Now IE is IE of B is less than that of A. Yes or no? IE of B is, sorry, here I made mistake. So here I wrote atomic radius of A is less than that of that to B. Now here I of B is less than that of A. Yes or no? Here I can remove electron easily because the distance between the atomic nucleus to the electron is more, and here also, here it is less. So I can remove the electron from B easily. So I need less energy to remove. So I will decrease. So we can write I atomic radius is inversely proportional or directly proportional? Inversely proportional. As atomic radius is increasing means ionization energy decreases. So atomic radius is inversely proportional to ionization energy. So did you get it? This one is one of the factor. Next, second one is the second one is screening effect, nuclear charge. Before that, nuclear charge, or else we can write screening effect directly. Screening effect. So what is meant by screening effect? So screening effect nothing but, so for example I have like this one shell, I have this atom, next one more shell is there here, next one more shell is there here, you just assume, and the nucleus is at the center of the shells. Okay, center of the shells. This is the nucleus, we can represent with plus charge. So electrons will be there in this shell and in this shell and in this shell. Yes or no? Now you just tell me the attraction force between the outermost shell and nucleus is more or less? It is less. Why? Because the distance is increasing here. Now one more thing also you can observe here. So the attraction force between the nucleus and electron is outermost shell is less. Now also you can observe here these two shells between the outermost shell and nucleus. These are called inner shells. Core shells, you can also call it as core shells. So these are acting like screen in between the nucleus and outermost shell. What these electrons are doing is, these electron between these two electrons also repulsions will be there, because they are having same charge, negative charge, so they have between them repulsions will be there. So because of the repulsions, these electrons wants to go out. This electron wants to go out because of the repulsions. The attraction force, also the attraction force between the electron, outermost shell electron and nucleus also will increase because of the repulsions. And because of these inner shells, the repulsions between the outermost shell and inner shell is increasing. That's why we can remove electron easily. Yes or no? We can remove the electron easily. We can remove the electron easily. So that's why when the screening effect is more means ionization energy also decreases, sorry. Screening effect is inversely proportional to IE. Why? Because here more screening effect is there. It is acting as a screen. These electrons are acting as a screen between the nucleus and the outermost shell. So if more spinning effect is there means less attraction will be there between nucleus and outermost shell. So we can easily remove the electron from here. So the ionization energy will decrease. Okay. So you can write here as, so you can write screening effect. What is the screening effect? As the number of electrons in the inner shells, or else four shells also we can find. Inner shells increases, then the repulsions between the outermost shell and the in, inner shells increases. So we can remove the electron easily. Electron easily. Okay, you can remove the electron easily. So the ionization energy decreases. So the screening effect is increasing means IE will decrease. Okay, got it? If there are very less shells, like very less inner shells means we can remove the, it is very hard to remove the electrons from the outermost. But here more shells are there, more screening effect will be there. Okay, so now we can write screening effect in the orbitals, increasing or decreasing we can write. Decreasing order, if we write means decreasing order is S P D F. Because the s orbital is close to the nucleus, that's why it will be more spinning effects, and the attraction force between the s electrons to the nucleus is more. Okay, that's why S has more spinning effects. Two more factors will be there. That two factors and for some example we'll discuss in the next class. Okay, so far what we discussed, ionization energy and the factors affecting the ionization energy. So what is meant by ionization energy? The amount of energy required to remove an electron from its outermost shell, that is called as ionization energy. So the units of ionization energy is, or electron volts per atom we can say, or else kilojoules in kilojoules per mole, or else kilocalorie per mole. And if we remove one electron from the neutral atom, that is first IE. Okay, we can write here first IE, IE1. So neutral atom, if you are removing the electron means that is IE1. Xe, so X plus is formed unipositive ion and negative. So here energy is observing, that's why these are called as endothermic reactions. Next, second IE means the energy is required to remove an electron from unipositive ion, is called as IE2. So here we wrote X plus IE, it gives the positive ion. So when we compare the energies between the energies required to remove from unipositive and neutral, unipositive is more. But in some cases, IE1 also will be less than IE2. That we'll discuss in the next lesson. And next, factors affecting in the IE is, first one is atomic radius. As atomic radius increases means ionization energy will decrease, because the attraction force between the electron and nucleus will increase. So we can easily remove the electron. Next, screening effect. The inner core shells acting as a screen in between the outermost shell electron and the nucleus. So when the repulsion forces existing between the inner shells and outermost shells. So we can easily remove the electron from the outermost shell. So ionization energy, less ionization energy needed to remove electron. So as the number of shells, number of electrons increases in the inner shells, so repulsion will be more in between the outermost shell and electrons. So we can easily remove the electrons. So we can write here spinning effect also inversely proportional to IE, and here atomic radius also inversely proportional to IE. Two more factors are, so one is penetrating power and another one is electronic configuration. We'll discuss that too in next class. And one more thing also we'll see in the variation trends in groups and periods from top to bottom and left to right, and we'll solve some problems in next class. So this is very important topic for IIT JEE and NEET. So follow, subscribe for more videos. Subscribe Rangiraju channel. Okay.